Assalamualaikum warahmatullahi wabarakatuh and good day. So we continue with chapter 5 again, okay, point 5.5, properties of point estimators. So basically in previous video, I have touched these properties of the point estimators. Okay, we have 4 things here. First is unbiased, second is consistency, the third one is efficiency, and the fourth one is sufficient. Okay, so the point estimator consider good if they have these 4 properties. So for unbiased properties, okay, we have discussed in previous video. You can watch in a subtopic method of moment, and also from previous video of the method of moment. Okay, we have many example about the unbiased. Okay, either this estimator unbiased or not. Okay, you can look again the previous video that we saw for unbiased. And then we have consistency, efficiency, sufficient. So in this video, I will discuss about relative efficiency. Number 3 first. Okay, efficiency. So by definition 9.1, given two unbiased estimator, theta 1 head, theta 2 head of a parameter theta, okay, with variance theta 1 head and variance theta 2 head respectively, then the efficiency of theta 1 head and relative to theta 2 head denoted this one. Okay, so usually we use efficiency like this. Okay, this is the notation. It's defined to be the ratio of variance theta 2 head divided variance theta 1 head. So this one you can see efficiency of theta 1 relative to theta 2. That's why variance theta 2 divided by variance theta 1. So this is the formula that you need to remember in order for you to check or to look either this estimator relative efficiency or not. So this is example page 446. Okay, you can look your textbook. So we have y1, y2 until yn denote a random sample from the uniform distribution, okay, on the interval 0 to theta. So you can see that your A is equal to 0, your B is equal to theta. So two unbiased estimator for theta are, the first one is theta 1 head equal to 2y bar and theta 2 head equal with n plus 1 over n times y bracket n. So this one, remember, this is ordered statistic. Okay, you know that when we have yn, we will have maximum value for all y value. So the question asks you, find the efficiency of theta 1 head relative to theta 2 head. So you can see when, in order for you to find the efficiency for this one, you will use this definition. This is the formula that you will use. Okay, but here look, theta 1 relative to theta 2. Is it similar? Yes. Then it will be variance theta 2 head divided by variance theta 1 head. So now look the solution. Okay, because you know that you have yi follow uniform distribution on the interval this one. Okay, you know that the mu or the expected mean for yi will be theta over 2. So basically actually b minus a over 2, isn't it? This is the expected y for uniform distribution. But here you can see that b is theta, a is 0. That's why you get theta over 2. And then the variance as well, you have a plus b, a squared plus b squared over 12. So when you substitute the value of a equal to 0, b equal to theta, you get theta squared over 12. Alright. So therefore, the expected theta 1 head will be expected 2y bar. Okay, because you have this one. Right. Then you bring out the 2 because it's a constant. Then you get this one. Expected y bar head is mu, isn't it? From previous video, you know that when we have the sampling distribution for y bar, it will be mu. So this mu actually, if it's followed uniform distribution, it will be theta over 2. So here you will get theta. Alright. So this is unbiased lah. Okay, because you can see that when we have e, y bar, this one should be equal with theta. So you get the same thing here. So it's unbiased. Alright. Now for the variance theta 1 head, okay, you have this one. And remember, this is variance. So when you bring out the constant, it's become 2 square. And then here you have variance y bar. Okay, but y bar, remember, the variance of yi should be divided by n. Okay, this is based on central limit theorem. Similar for this one. Okay, remember. And then you substitute this one, variance yi, which is you get theta square over 12. and then you multiply, substitute, simplify, you get theta square over 3n. Alright, so now we look the variance and the mean for theta head 2. Okay, so you can recall or see exercise 6.74, okay, that the density function of yn, okay, because this is order statistic, so you can look back the video which we discussed about order statistic. So based on that video, okay, we have this density function, okay, whereas gn, this is ordered y, we will have this one, and this is the density function, you will have this one. Okay, so based on this density function, okay, that you learned before in order statistic, the expected yn will have this one. Okay, you have n over theta n, 0 until theta, because you know that this is uniform, then your y is between a and b, and then y power n delta y, dy. Okay, so when you differentiate with respect to y, you will get this one, and then substitute the value theta, you will have n over n plus 1 times theta. Okay, so it follows that the expected value for this one will be theta. Therefore, that is theta 2 head is also unbiased estimator for theta. So you can see that both are unbiased. Okay, so this one is unbiased, this one is unbiased, so it's a good properties. Okay, but here we want to see either it's a relative efficiency or not. Okay, so because we have expected variance square ordered will be this one. Okay, so that's the difference. Okay, you can see that, I mean, you have done this in ordered statistic video, right? So you will have n plus 2 times theta power 2. Okay, because you have here square. If you have k, so here will be n plus k theta power k. Right, this is based on the theorem that you learned before. Then based on this one, we will obtain variance yn ordered equal with expected y square n minus expected yn all is square. So you just substitute the value that you found previously. Right, so you have here n plus 2 minus n plus 1 square, and then you factorize the theta square. All right, because you have here theta square, and here will be theta square as well, so you can factorize. And then for the variance theta heads 2, you will have variance this one. Okay, here you can see. All right, this one is theta 2, isn't it? Okay, you have n plus 1 n, and then yn. Okay, so this one you can bring it out. Okay, this one you can bring it out because this is a constant. Make sure you square because this is a variance. So variance yn will be this one. All right. Variance yn will be this one. Okay, and then you substitute here, and then you simplify. You will get theta square over n plus 2. Okay, and then you need the relative efficiency. So for relative efficiency, you will have this formula. So you just substitute back what is the variance theta 2 head. So this is what we get. And then variance theta 1 head, this is what you get. Then you simplify this one, you get 3 over n plus 2. So if you look here, the efficiency is less than 1 if n greater than 1. That means if you have 1 here, or if you have 2 here, okay, 3 over 4 will be what? 0 point something, isn't it? Okay, so it will be less than 1. So if theta 2 has a smaller variance than theta 1, okay, therefore theta 2 is generally preferable to theta 1 head as an estimator of theta. That means which one is the best when you have the smaller variance? Okay, in here you can see that theta 1 head, okay, this one, you get this one. Okay, so if you have n here greater than 1, which is let's say 2, so you get 3 over 4. 3 over 4 is 0 0.75. Even if you divide by 3 over 8, you will get less than 1. Okay, so if n greater than 1, your theta 2, this one, has a smaller variance than theta 1. So therefore theta 2 is more preferable compared to theta 1 because it gives you a smaller variance. Okay, so it's preferable to be an estimator of theta. All right. So I skip a few things here. For example, to simplify this one, okay, there are many steps which is I skip, okay, because it's just previous knowledge that you need to use, okay. So I suggest you to try again, do this example, use your own solution. I mean, for sure guided by this solution, but don't skip, okay. For example, like this, make sure you know how to solve this one, how to solve this one as well. All right, so that's how you check the efficiency for the estimator. All right, so you can try exercise question 9.1 until 9.9. If you have any difficulties or if you have any problem to understand this subtopic, you can ask me. Thank you, class.